Greetings from K.S.Rangasamy College of Technology. Myself, U. Vivek, Assistant Professor, Department of Mechanical Engineering, K.S.Rangasamy College of Technology. Today I have take the subject Kinematics of Machines, particular module Friction Drives. First of all, what definition for friction? A friction, a force that opposes the motion when the force is applied to the body resting on the rough plate so that the body is moves or tends to move. The frictional force act on the body in the opposite to the applied force. Example, see the image. The man is push the object in the leftward direction. The blue arrow direction is the motion. The friction will be creating in the opposite of the movable body. So that is the easy example for the friction. A unit of the friction is also same for the force unit. It is a Newton. It depends on the friction is weight of the object is normal force. The nature of the surfaces between the moving object and the supporting surface. So this is the general definition of the friction. Next I come to the friction drives. A mechanical drives in which motion is transmitted or converted by the frictional force between the rolling body, cylinder, cone and like that are placed against each other. The frictional drive is may be used to transmit the motion between the having a parallel to or transfer axis of the shaft to convert the rotary motion to helical motion and convert the rotary motion to translatory motion. They have the fixed or variable gear ratio. So basic of the content of the friction drives is the first one is a belt drive and a rope drive and a chain drives. So we have to discuss one by one. Next we have to friction drive advantages. The major advantages of the friction drives to drive the drive can also work as a clutch. It is a possible to change the rotations while machine or is running. It is a immediate equalization when the friction wheel slip. And also drawback of the friction drive, the pressure on the shaft or bearing. And second one is the instability of the gear speed ratio. Next topic is the belt drive. So nowadays the belt drive is mostly using in the all the automobile sectors and also industry side also. Example, the belt drive is mostly using in the compressor and lathe machines and grinder and home application side also belt drive is. The basic definition of the belt drive: a belt is a flexible power transmission element that sits the tight or set of the pulley or sieves. The belt is designed to the ride around the two sieves without slipping. The belt is installed by placing it around the two sieves. While the center of distance between the is reduced, then the sieves are moved apart. The placing the belt is in a rather high initial tension. When the belt is transmitting power, friction causes the belt to grip the driving sieves, increasing the tension in the one side is called the tight side of the driven. Another side is the slack side, that is a loose side. Next, what are the selection factors to consider in the belt drive? First of all, speed of the driving and the driven shaft. Second one is the speed reduction ratio. Third one is the power to be transmitted. Fourth one is the center distance between the shaft. Fifth one is the positive drive requirements. Next one is the shaft layout, space available, and service conditions. These are the selection category of the belt drive. And types of belt drives in the totally in three category. One is light drives, medium drives, and heavy drives. It is based on the speed. First one is a light drive. These are used to transmitting the small power at the belt speed up to about the 10 meter per second, as in agriculture machines and smaller machine tools. Examples of the light drives. Next one is the medium drives. These are used to transmitting the medium power at belt speeds over the 10 meter per second between to up to 22 meter per second. Examples in these machine tools applications. And next one is a heavy drives is more than speed up to 22 meter per seconds. Example for using in the compressor and the generators. These are the types of belt drives. The next using the types of belt. First one is a flat belt, second one is a V belt, and third one is a circular belt. The flat belt is mostly using in the factories and workshop where a moderate about the power is to be transmitted from the one pulley to another when the two pulleys are not more than the 8 meters. So that side only we are using the flat belt. And the next one is a V belt. Majorly we are using the V belt in the all the areas. It is used in the factories and the workshop where the moderate about the power is to be transmitted from the one pulley to another when the two pulleys is very near to each other. So compared with the flat belt, V belt is the more flexible. And last one is a circular belt or rope. The circular belt or rope is mostly using in the factories and workshop where the gray amount of power to be transmitted from the one pulley to another when the two pulleys are more than 8 meters apart. Next, what are the materials using in the belt? First one is the balata belt. It's balata is it is a same similar to the rubber belt material, but is more stronger than the rubber belt. And the next one is a leather belt and cotton and fabric belt also using in the belt drive side. Next is the types of flat belt drives. So see that example, it is a open belt drive. You have to see the open belt drives. It is a driving pulley. A is a driving pulley, B is a driven pulley. So A driving pulley is a diameter is a high, B is a small. It is connected with the belt. It's a higher example. A is a driving pulley. It is rotating in the clockwise direction. It is a belt will come from the A to B. So higher dia to lower dia. So we have to create in the slack side. And similarly, next we come to the B will be rotating also this direction. Belt will power to be transmitted from the B to A. So this is the tight side. So one is the slack side, another is the tight side. Example for the open belt drive. Similarly, the rotation will be come from the quarter turn belt drive, crossed belt drives, and a belt driving and ideal pulley. So same all thing will be followed in these directions. Next, we have to calculate the velocity ratio of the belt drive and the speed. Here is the mean for the speed. It is a n2 divided by n1 equal to d1 by d2. So we have to discuss one by one. D1 is the diameter of the driver, D2 is the diameter of the follower, and N1 is the speed of the driver in the RPM, N2 is the speed of the follower in the RPM. Length of the belt is passes over the driver in the 1 minute. It's a pi dn. And similarly, length of the belt is passes for the follower is a pi d2 n2. So next we come to equally we to transfers pi d1. It's a n1 equal to pi d2 into n2. It's a pi by it's a cancel. So we have to get the velocity ratio n2 by n1 equal to d1 by d2. When the thickness of the belt is a notation at is a t is considered the velocity ratio. So final of the equation is simplified from this one n2 divided by n1 equal to d1 plus t divided by d2 plus t. So n2 is a speed of the follower, n1 is a speed of the driver, and d1 is the diameter of the driver, d2 is the diameter of the follower. Next of the rope drive. So rope drives are widely used where larger amount of power to be transmitted from the one pulley to another over a considerable distance. It's maybe is noted the use of flat belt is limited from the transmission of moderated power from the one pulley to another. When the two pulleys are not more than 8 meters apart, if large amount of power are transmitted by the flat belt, then it's a could result is excessive to the belt cross section. It may be is not a very frictional grip as the rope drive more than to the V drive. So example, see that this is the rope drive images. So this line is the wire. It's a strand and core wires. It's strand in the steel or fiber. The rope drive is mostly using in the spinning mills of the line shaft. Each floor is driven by rope passing directly from the main engine pulley or around the ground floor. The two types of rope drive you are using. First one is the fiber rope, second one is the wire rope. The fiber rope is operated successfully when the pulleys are about the 60 meters apart, while the wire rope are using in the pulleys up to 150 meters apart. It is wire rope is mostly using in the power plant industries and around rope conveyors and elevators. Major application we are using in the wire rope side. Next one is the advantages of wire rope drive, sorry, fiber rope drive. They given the smooth, steady, and acute services. They are a little affected by outdoor condition. The shaft may be out of strict alignment. The power may be taken from of any direction and the friction apart from the oil amount. They have the high mechanical efficiency. This is the major advantages of the fiber rope. Next drive, we have to discuss the chain drive. So, a compare we have to already see the belt drive and rope drive. Compare with these two drive. The chain drive is a high velocity ratio will be transmitted from the one ratio to another. It is without slipping. The belt drive side is a slipping is a major problem, and you are using the chain drive. Slipping problem will be reduce it. We have seen the belt or rope drive is that is slipping may be occur. In order to avoid the slipping, steel chain are used. The chain is are made up of grip links which is hinged together in order to provide the necessary flexibility of wrapping around the driving and driven wheels. So this one is for the sprocket wheels. This is a chain. So similarly, we are to rotational. One is a driving, another one is a driven. So we are to rotational, so without slipping. Reason is they are the similar to the spur gear. So teeth will be there. So the slipping problem will be can to avoided for the chain drive. These are the major types of chain drive. First is the roller chain, slant chain, leaf chain, flat tape chain, and engineering chain. So these are the various types of chains using in the all the applications. Advantages of chain drive over to the belt or rope drive. Compare with the rope and belt, what are the major advantages? As only no slip take the place during the chain drives. This is a major advantages. Is the perfect velocity ratio is obtained since the chains are made of metal, therefore they occupy the less space in the width of the belt. And also the chain drive is a high transmission efficiency up to 98 percentages. So you are going to avoid the slip as the power also will be high. So that is the point. The chain drive is give the less load of the shaft. The chain drive has the ability of the transmitting motion to several shaft by one chain only. And also drawback of the chain drive compared with the over or belt drive. The production cost of the chain is relatively high. The high chain drive, the chain drive is needs accurate mounting and careful maintenance. The chain drives has velocity fluctuation, especially when the stretched. Thanks for watching video. Keep learning and growing. Thank you.